So today what I want to do is to not only show you the unit circle, but show you why we're doing the unit circle. And to get to that point, we're probably going to need to start with what's sine and cosine anyway. So if you take the xy axes, and what's the easiest radius of a circle there ever was? Other than 0, because 0 wouldn't be a very interesting circle. 1, right? And we call it a unit circle because the radius is the easy one, 1. You can have it any radius, and we'll deal with other radii, but this is really easy, radius equal to 1. So if we have a radius equal to 1, we might end up with a point x comma y on that circle. So we're going to be a little more clear about that. If we have a line that goes out to the circle, radius 1, at an angle we'll call theta, we'll generate a nice looking triangle, right triangle, where this is theta, this is right angle, this is 1, and then if we go over x up y, xy, we can respond to this with SOHCAHTOA. What's the cosine of theta for this yellow triangle? Cosine is opposite or adjacent over hypotenuse? Opposite is sine. So sine is y over 1, and cosine is going to be adjacent, x over 1. So what this means, when you have a radius of 1, you don't need to say xy. You can say 1 times the cosine of theta, comma, sine of theta. So every time you're looking at a coordinate on this circle that's anywhere on the circle, the cosine is the x and the sine is the y. That's huge. You're going to be confused by that sometimes, but don't be. All right, so let's say that somebody asked you, find the sine and cosine for these degrees. So I'm going to pick, start with this one. Theta is 270. This is 90, 180. 270 is this angle right here. Right here is 270 degrees. And the first thing I would do is I would make a coordinate. So I'm going to get rid of this. And I'm going to put in a coordinate. Let's see. Yeah. So I'm going to take the coordinate down here. How far over am I if I'm going down to this spot? I'm over 0, down what? 1. So 0, negative 1. This is the coordinate xy. What's the cosine of 270 then? Is it the 0 or negative 1 for cosine? Cosine is the x, so 0, yeah. So that'll be 0. And then the sine of 270 is just going to be the y part, negative 1. And there you have it. Let's try some other ones. 45. Well, 45 is interesting. It's right here in the middle. This is 1. Well, 45, 45. This is going to be 1 over the square root of 2, and the y is 1 over the square root of 2. It's going to be both of those. So what's the cosine of 45 degrees? The x or the y? Well, it doesn't matter. It's going to be the x, but it's still the same for sine and cosine. All right? If I told you for 60 degrees, the coordinate at 60 degrees is going to be 1/2 comma square root of 3 over 2. What would you say the cosine of 60 is? And the sine of 60. Then what's the cosine of 60 going to be? Yep, it's the x part, 1/2. And then the sine is the y part, square root of 3 over 2. That's why we're going to be doing what we're going to do. All you have to do from here on out is how do we get all of these values. So go to this slide that says unit circle. This is what you're going to produce. You're going to produce, I'm going to give you a grid on tomorrow actually, and on Friday. And then Friday's going to be the quiz. Tomorrow you're going to get a practice one. You're going to put all the degrees, all of the radians, and all the coordinates on this. And it's not hard, it's just a little weird. And we're going to start by, would you just make some little lines going here, 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 and there. There's an infinite number of degrees and radians on this circle, but we're going to pick the ones that are used the most, and they're, frankly, you know, they're probably the easiest to derive. We'll do it because it's easy. We're going to start with the angles. So this arrow here is what we usually refer to as 0 degrees. Then as you go counterclockwise, you'll get 90. Counterclockwise, you'll get 180. What will this be down here? 270, yeah, and then 360. Okay? If you take a third of 90, 1/3 of 90, you're going to get this spot here. This is third, 2/3. So a third is 30. Double that, you'll get 60. Add 30, you get 90. This is another, a third of that will be 120. Then another 30 will be 150. Another 30 will be 180. And you can see how I just keep adding 30. 300 and 330. If I add 30 more, I better get 360. Yep, and I did. We did leave somebody out. We left out half of 90, which is 45. And then we add 45 to 90, you'll get 135. Add 45 to 180, you get 225. Add 45 here, you get 315. A student told me once, if you're adding 90 between these, it's 4, 3, 2, 1. So a way to remember it, but you're just adding 15 and 30. That's all. That probably isn't too bad, is it? No. Next, what we're going to do is we're going to, next what I want to do is I want you to add the arc lengths. Now this could be hard, but for you it won't be. This is 0 radians, and this is pi radians. And if you go another pi, it'll be, you could also say 2 pi radians if you want. What's midway between 0 and pi? What's that going to be? Midway. Pi over what? 2. So you have pi over 2, pi, 3 pi over 2, 4 pi over 2, which is 2 pi. To get the more challenging ones, we're going to take pi over 2, and then I'm going to take a third of it. What's a third of pi over 2? Pi over 6, yeah. So we're going to take a third of pi over 2. A third of 90 is 30. Pi over 6 goes here. And then it'll be 2 pi over 6, which, by the way, is pi over 3. 3 pi over 6, which is pi over 2. 4 pi over 6, go just 30. 4 pi over 6 is 2 pi over 3. 5 pi over 6. And if we did it right, 6 pi over 6. Great. 7 pi over 6. 8 pi over 6 is 4 pi over 3. 9 pi over 6 is 3 pi over 2. 10 pi over 6 is 5 pi over 3. And then you're going to get, this is 10 pi over 6. This will be 11 pi over 6. And then that will be 12 pi over 6. We did leave out, oops, I forgot. I left out the pi over 4s. So half of pi over 2, half of pi over 2 is pi over 4. So 45 plus 45 plus 45. So pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, 7 pi over 4, 8 pi over 4. All right, last thing. Now, the last thing on the unit circle that you have to do is you have to put the coordinates. So if we have a coordinate over here, and I'm going to use, let's go dazzling blue, Minnetonka blue. All right, so to get to this point here, we go over 1, up 0. To get to this point up here, we're going to go over 0, up what? 4? No, up 1. And this will be back 1, up 0. This will be over 0, down 1. So those coordinates are easy, right? And then to get all of the rest, we're going to use a little strategy that I call making rectangles. And I think you're going to like it. But I do have to say this first. How many points are there on the circle? Emma, how many are there? Are there like 4 or more? Infinite, right? So when I say find these coordinates, these are just a few of them. But they're the ones that we pick because 30, 60, 90 are triangles that we know how to deal with. But instead of memorizing these, all I want you to do is memorize 2. Can you memorize 2 coordinates? 2? Yeah. And I'm going to use this box method. I'm going to take a box. I'm going to go right here, go down to there. If you can do that on yours, that would be great. If you can't, it's okay. What this box means is that we're going to find out what this coordinate is. All of these coordinates are the same distance up, same distance across. We just have to deal with the plus minus signs. But before we do that, let's talk about 30, 60, 90. Here's 30, 60, and 90. This is 1. On a 30, 60, 90, the short side was half. And then we took a half and we multiplied by the square root of 3 over 2. This helps us build the coordinate over square root of 3 over 2 up 1/2. It's just the 30, 60, 90. Now you see why I taught you that. Then on this rectangle, we're just going to replicate that point. Square root of 3 over 2, 1/2. Square root of 3 over 2, 1/2. Square root of 3 over 2, 1/2. And the rectangle kind of shows you where those are. And then in quadrant 1, both x and y are positive. But in quadrant 2, the x is negative, the y is positive. Both are negative in quadrant 3. The x is positive, the y is negative in quadrant 4. So when we look at these, they're not quite identical. This one's negative, both of these are negative, and only the y is negative for that. Do you like that rectangle? It makes it pretty slick. Let's do this for another one. Let's do this for the 60-30 triangle. So we're going to take this one, make a rectangle, and then I'm going to go 60-30 this time. Now this is still 1. This is going to be 1/2. This will be square root of 3 over 2. So everything's going to look the same. My x is just going to switch with the y from the pi over 6. They're just going to be switched. So you don't even have to memorize this. It's just the reverse of this one. So then wherever the rectangle is, put in 1/2, square root of 3 over 2. Square root of 3 over 2. Like that. And then we notice that this y was negative, x and y are both negative, and the x is negative for that. So we have one more triangle to go. And that triangle is the easiest of all, 45, 45. So if this is 45, 45, this is 1. This will just be 1 over the square root of 2. So will this one. So if you want to, make yourself one of those rectangles. It's the ones that are left. And then just go ahead and put in 1 over square root of 2, 1 over square root of 2. 1 over square root of 2, 1 over square root of 2. All of these are 1 over square root of 2's because they're at the 45. And then put in the signs so they're consistent with the quadrant. And there is your unit circle. Looks like somebody threw up on the smart board after eating Skittles. Yeah. But this is what you need to know so that you can answer this burning question: what is the sine of 5 pi over 6? Turn to your neighbor, tell him what the sine of 5 pi over 6 is. What's the sine of 5 pi over 6? Well, what you do first is you find the arc length, 5 pi over 6. What is the matching coordinate? The matching coordinate is negative square root of 3 over 2, 1/2. Now, if we're looking for sine, is that the x or the y? Sine. It's the y. So your answer is just 1/2. And you can find the cosine of 150 degrees. You can find the tangent of 11 pi over 6. It's all there. It's all there on there. All you have to do is have this. Now we're going to look at shortcuts on how to do portions of it, but this is why you do it. All right, and then here's a shorter version of it if you need it. And then the last thing I wanted to mention is, what if the circle isn't a radius of 1? Can we deal with it? And the answer is absolutely. What if they tell you you're in quadrant 4? Here's 1, 2, 3, and 4. And the sine is blah, blah, blah. We're in quadrant 4. Draw a line like this. I want to use a different color, though. Would you just take a moment on that slide, draw a circle, and then in quadrant 4, draw a line, and then don't go across, go up to the x-axis. Always go to the x-axis. And then we're going to make a triangle like this. And then do what it says. Sine is 7 over 25. Well, sine is opposite over hypotenuse. Now, the hypotenuse is never, ever negative. Only the sides are. So if one of these is negative, it has to be the 7. And then I think, what's 25 squared minus negative 7 squared? Is that 23 squared? I think that's a triple. I'm guessing it's 23. So you finish off the triangle, and then now look at this triangle. What's the cosine of theta? Cosine's going to be 23 over 25. There you go. Let's try the next one. If the cosine of theta is 4/9 in quadrant 1, well, quadrant 1, you make a line here. Never go to the y-axis, always go down. So here's the triangle that we're going to make, theta. Then write what it says. Cosine is 4/9. This side is the square root of 9 squared minus 4 squared. I think that's 81 minus 16. I think that's the square root of 65. Positive in quadrant 1. Now, answer the question. What's the sine of theta? Sine is going to be opposite over hypotenuse. And now you should be able to do the problems having to do with using the unit circle. And I'm going to go to that right now. Using the unit circle. So, for example, number 1 here, it says theta is 0. So they want to know what coordinate is that. Well, if you go to your unit circle, look at it. At 0, it's going to be 1, 0. So the cosine of 0 is which one, 1 or 0? Raise your hand if you think it's 1. Raise your hand if you think it's 0. Okay, raise your hand if you thought it was 1 again. There you go. So it's 1, and then the sign is 0. Okay, go to number 2 here. It says, oh, that was too easy. Go to 3. Go to the unit circle, find out what's the coordinate first. At pi over 3, it's going to be over a half up square root of 3 over 2. So then you just write cosine of pi over 3 is going to be the x, and the sine of pi over 3 is going to be the y. This seem too easy? It's pretty easy. This will challenge you a little bit. I'll be interested to see what you do with some of those latter ones. And then with these, you're going to draw the circle, make the triangle, and then answer it.